Good morning, everyone. I'm Ren, and this is episode 9 of Farm and G's Livestream. Another gorgeous sunny day in Watsonville. I'm here with Edgar and Kyle, two of our engineers. They're going to guide us through the technical side of the Amiga. Last time they introduced us into developing an app using Kivy. Today they're going to dig a little bit deeper and show us some specific examples and some code. If you have any questions, something specific you want to see, hit us up in the chat. Thanks again for joining us. Take it away, Kyle.
All right. Good morning, everybody, and or afternoon or evening if you're Edgar in Spain. I'll introduce myself. I'm Kyle. I'm a software engineer, robotic software, computer vision, and vehicle firmware here at FarmNG, working on the Amiga.
Okay, cool. Hello, everyone. I'm Edgar. I'm also a software engineer, FarmNG, working same area, robotics, computer vision, and focus on the brain side.
And so our plan for today is to keep going through app development for the Amiga. So we're going to build a Kivy application. It's kind of a follow-up to last week, Livestream number 8, where we introduced Amiga App Development. And this time we will go a little deeper into it. Anyone have anything else before we dive in?
I think it's fine.
I think we're good to go.
Cool. Okay. So last week we set up a custom application on the Amiga. So maybe I'll talk about the setup we have here. We have this application called Custom App Demo that we built off of the Amiga App template. And this is, you clone the repository onto the app, and then you can make changes to that application. You can develop immediately directly on the Amiga. So right now, this Amiga screen is a VNC view of an Amiga that's on Larry Jacobs' farm, where we're doing a lot of our development and testing. And I am back in the comfort and warmth of the office. And then I have a VS Code window, and this is also what we did last week, was we set it up all through the VS Code window so that my Git credentials and everything are handled on my computer by VS Code, as opposed to needing to set them up on the robot. And so this is an SSH VS term window. So this is editing code directly on the robot, which is a very convenient way to develop. Okay, so yeah, right now our app is basically, and you'll see right now it's showing the Git differences. It's basically just the app template. I'll even put that back to before, with some renames to the library to be Custom App Demo, because that's what we're calling our package. So right now the Kivy implementation is very simple. All we're doing is displaying a label that counts as you go through, in a loop that runs forever. One thing when you're implementing your Kivy application, please keep this back button there. Otherwise, you might get into a situation where you can't close the application from the screen, because when you pop up your app, if you configure it the way we recommend at the top, where it takes up the entire width and height of the screen, and it's not resizable, basically this ensures that when your app is up and it's launched and you're interacting with it, you're touching it, things like that, you're not accidentally interacting with the launcher in the background and starting other apps or other processes, or maybe you accidentally click in the right spot that turns off the camera service and then your camera stream dies. So keep the full graphics configuration, and then keep this back button. You can move it, of course. It's on a on a relative layout. So you can position it wherever you'd like to get it out of the way if you want that top left corner. But please keep something so that you can exit out of your app if you launch it by the touchscreen. And then the other Kivy widget that we have in here is just a label that's displaying a text string that we edit. So what we would like to do is we'll start off with the camera streamer. We have a tutorial for this. See, on our FarmNG website. We have, so this is the home page. If you go to examples and Brain App tutorials, you'll see kind of last week we went through the tutorial introduction more or less. This week we'll start with the camera streamer. So the idea is, you can read through this tutorial and try to follow along, and then this is additional context and kind of talking through and explaining things that maybe might be missed in the text. So that's what we're going through, and that corresponds to this camera streamer repository, which is an app that you can download directly onto your Amiga and just have it for you to use.
Yeah, maybe remark that what we're going to do today is to start from the basic template example and just adding pieces, right? See, all these pieces that we have now in several apps, like the camera streamer, there's the virtual joystick, but the intention today is to show how to start from the very basics and just keep adding small functionalities to achieve the same level of like in the other apps, to show the cameras, interact with the canvas. If we have time, also to send some signals to move the robot.
Yeah, exactly. Yeah, good point. Okay, so should we kind of define our Kivy window and what we want to see?
Yeah, well, maybe it's worth to kind of revisit the structure of the basic template app and point out the things that we expect there. Yeah, talk about a bit of the structure in general.
Yeah, maybe should I bring that up?
Yeah, maybe if you scroll a bit down. Oh yeah, here.
You mean the project structure?
Yeah, project structure, and then yeah, the structure also of the basic class, the app class, and yeah, we can discuss all the things that needs to be updated or in which different ways you can keep adding things there.
Yeah. Do you want to talk through it, Edgar?
Yeah, sure. So basically, every time that you will fork or clone the template app from FarmNG, the organization, we have this repository called template app. The idea is that you clone. This is a GitHub template. So basically, you will get in your user or the user you select fork of that project. This project, we have the structure of the project is assumed to be what you see here in the screen. So the repository name, it's an arbitrary name that you later should modify based on whatever name you want to give to your app. And then we have 1, 2, 3 main directories, which is libs, source, and test. And then we have this entry data stage, which is the entry point to execute the app. The setup.config, this is something that we covered in the previous session. It's where you will define all the metadata, if there are dependencies, or you want to add, remove some dependencies. And then in the 3 different directories, libs is where you want to implement kind of internal libraries that you want to use in the main app. in source, you will have to place basically assets, images that you want to show in the app. If you have videos, in also the Kivy language definition itself is something convenient to have it abstracted in a way. And then the main.py, it's the actual Python entry point, which we are going to start to modify now. It's the definition of the class where it will define all the, we will discuss also that the different concurrent methods that we can have in the app. And last, test. This is something, some of the good practices that we like to enforce. We recommend to add tests in your code. So that's why you have a test directory here.
And then entry.sh is where you can add any, this is what actually launches the program. And if you want to pass any command line arguments, you can use entry.sh for that. And setup.config is where you add any dependencies that you want to add, just to complete it. And yeah, so Edgar mentioned you can add libraries and libs and develop your own custom packages that'll be used in the main.py. So you have kind of two options. Is one, you can just sort of put everything in main.py while you're developing, but then your main.py gets massive and hard to find anything. Whereas if you start kind of dividing out separate things and things that are possibly reusable in other applications that you might develop, that's when kind of moving to libs, I think, makes the most sense.
Yeah, I think that the more you can abstract and separate code, it's later easy to maintain. That's a thing, a good practice to follow.
Yeah, and easier to test too.
Yeah,
to have tests for your
Well, maybe a recommendation here actually is something that happened to us when we started to implement the apps in Kivy. Something that happened is that we were developing the app, everything in all self-contained, right? And that's actually a good point that you said, that for testing, having separated code, so trying to abstract the GUI code from code that implements some logics or interaction with other components or libraries. So it helped, trying to abstract that, it helped a lot to maintain the code. Otherwise, you are just making everything integrated to the GUI, and in the long term, it's in the end you have a big ball that sometimes it's difficult to or debug. So yeah, highly recommend it to abstract code in separated directories or small internal libraries.
Yeah. Okay. Yeah, let's get into it. So I think we'll start with defining the Kivy application that we want to see. So where's my VS Code? So in source res main.kv, this is where our main Kivy app is defined. And we can, so first thing we want to do is we want to make a place for us to put up our images. I think there's a few options. So the Oak cameras that we're using stream 4 image streams by default, optionally a 5th if you want to upload neural network weights to the Oak. But maybe that's not something we're going to get into right now. So the basic stream is 4 images: a color image, a left image, a right image from the stereo camera, and then a disparity image. So in order to display those 4 images, you could put 4 images in kind of a quad grid, or what we like to use is a tabbed panel, which is one of the Kivy widgets that I'll bring up here. And the this allows you to have kind of, we can put the 4 image streams, each one on a tab, and then you can select which one you want to be viewing at the time. So you'll see I just Googled Kivy tabbed panel to find the API for it and their documentation. The Kivy.org docs are super useful and robust. And maybe another thing is these Codemy videos might be helpful when you're getting an introduction to Kivy. They're a good introduction to kind of Kivy apps and widgets. But once you're going into like the ecosystem of running it on the Amiga with async IO and gRPC, they definitely do not get into that. So anyway, so you can check the Kivy tabbed panel documentation here. You can see all of the usage and So for us, we can add, we can remove this label, which we'll no longer use. And we'll add a tabbed panel inside our relative layout. So this relative layout is going to be the main, this is our main layout, and we can have nested layouts inside this. But this will be like the main layout of our application. So
yeah, I think it's also worth for anyone starting with Kivy to read about the different layouts, because it's also we had also internally at some point, right, some discussions how to define the different layouts, etc. It's there are so many ways to represent how you want to visualize basically an app, the widgets, etc. So Kivy provides different types of layouts, some of them more and the other less flexible, depending on what you want to do.
Yeah, and the relative layout is nice because it's similar to a float layout where you can position things where you want, but rather than using, you can use like, on the scale of 0 to 1 of where you want it to be, which I think is a little easier for us to think of as opposed to like in raw pixels. And then we use a lot of box layouts just as it's easy to line things up, and then you can adjust the relative size of them. Grid layouts, stack layouts, all we have a little bit of everything. Maybe not scatter layout, but
probably the most one, the one we use the most is box layouts, because it's easy like to just stack or vertically or horizontally. Then, as you said, so each layout you can pass different parameters just to adjust sizes based on relative sizes also.
Yeah, you can use the size hints to change. And box layout is a good one just to like start throwing your widgets in there, and then once you have everything that you want, then you can start cleaning up the UI and moving things and positioning. Okay. So our tabbed panel will, I think we'll take the whole screen for it. I think one thing you'll notice is, so the tabbed panel and the back button are going to be drawn in the same spot. Like they're both going to be drawn from the top left corner. So we put the tabbed panel first so that the button is drawn on top of the tabbed panel. Otherwise, the button would be hidden and you wouldn't actually be able to click it. So that's pretty important. And then we can start adding. So inside the tabbed panel, you add tabbed panel item, or the widgets. And for these, you give them a label. So for the first one, we'll call it RGB. We'll add 4 of these tabbed panels items.
Yeah.
So we'll have an RGB, a left. Oh, sorry, what's up?
We'll just copy paste from the example we have already.
That's less fun. And then a disparity for each of these tabbed panel items. So you could put any type of widget you wanted. Like you could put a button here that does like like reset or something like that. But we want to put an image widget in each one of these. And for each image, we want to give it an ID so that we can reference the image widget. So now with this, and you'll see this a little later when we get into the Python code, but this ID will allow us to go like, say the root application .IDs, then we can access any of the widget IDs. So we can say root.IDs.RGB or root.IDs, and then use it as a dictionary to find IDs or RGB. And that will allow us to access this image, and basically like we'll stick the image in there as a Kivy texture. Okay, so we'll also have a left.
Yeah, and also I think it has this kind of bidirectional behavior, right? That from here, the Kivy language, you can also call Python functions defined in the widgets. So yeah, it has, so the Kivy language is kind of powerful in that way, that you can have the Kivy language and then your Python code, and from both sides you can interact with each other.
Yeah. Yeah, and maybe we'll show that a little. I don't know that we'll have that necessarily in this app, but maybe we can just demonstrate it, or we'll show it for the virtual joystick. Okay, so now we can try to launch our app. I think it should crash probably. So I think it's looking for the label that we deleted. Let's see. ID counter label. Okay, so now that ID, sorry, I'll show that more clearly. Now that we've deleted the label with counter label, you'll see in main.py, we were trying to set that value to say tick and tack as we went through this template function. We're no longer doing that. So if we comment that out, and we'll just delete this template function in a minute. But if we comment that out for now, we should be able to run our Kivy application. Okay, so now we'll see we have our 4 tabs. Actually, we have 5 tabs. So what do we have up here? It's hard to read it with the back button. So let's maybe shift the back button down a little bit. What's I don't know, 0.9, we can come down. And let's launch that app again. Okay, oh, so we have a default tab. Okay, so the tabbed panel has this feature where it can have a default tab that you can turn off. So we'll do, and if you look in the API for it, it'll tell you, do default tab, set that to false. That'll remove that. Maybe we shift the button up a little bit. Since it was kind of low. And let's try launching it again. Okay, now we have a tabbed panel. They don't look any different when we go to each one because they're all just blinked images. But we kind of have our where we want to stick everything set up. And we have our back button drawn on top. I don't know. Okay. So that basically is the entire Kivy implementation that we need for this. And now we can get into the actual Python implementation. Okay, so where to start? Maybe we'll define the arguments we want to pass first.
Yeah.
So
well, maybe we can explain here, what the structure of this file, right? What are the main components? This template app, what does it mean? The different functions.
Do you want to?
Yeah, sure. So basically, in this file, so every Kivy app in our setup will assume that we'll have this class. In that case, it's template app, but it's a class that inherits from app, which is a Kivy app class. And this is kind of the main object to start the application. If you see, there is always this build function that basically is using the builder object from Kivy that will load the Kivy language definition that we were just modifying right now, that has all the layout using the different Kivy widgets. And then we have, as Kyle was saying before, like a safety function that it's linked to the exit button. This on exit button, this is something that we highly recommend to keep it, don't delete it. Otherwise, you can get stuck in your program. And then maybe,
and this is a good example, Edgar, of what you were mentioning before with being able to link the Python functions to the Kivy
yes,
widgets.
Yeah, exactly. If you see here on the right side in the Kivy language, in the exit button, so all the widgets, they have different callbacks, hooks related to different events, basically. And the button widget in particular, it's something that you might want to use very often. It's the on-release callback. So that basically here you will define every time that you release, that you press and release a button. Here, what we're saying is that, hey, call from the app. So this will refer to the root app object in your application. Then call this function call on exit button. And this is how we are linking from the Kivy language, making a function call to your Python implementation.
Mm-hmm.
And yeah, would point here, Kyle, that's worth to check. Every widget, they have specific callbacks, events. Yeah, it's a whole set of, knowledge in Kivy about the different events. So it's worth to read about that. Yeah.
And we like to use on release as opposed to on press. That way it's, you press down a button and then you let it go and then it triggers, as opposed to pressing it and it happening right away. Because then that gives you the ability to drag off and not release it, which is nice. And yeah, if anyone's jumped in the middle, we'll just give a little context. We are going from our app template, kind of going through the developing custom applications, where we have this base application, and we're setting it up to stream the camera images off of the Oak camera that comes with the Amiga intelligence kit. So we've defined our Kivy layout, where we have a tabbed panel to put all of those images, and now we're going to start editing the Python code to stream those images and put them and display them in the Kivy app.
So in this main class, we have one of the important methods is, you will see that we call it app function. That's basically a wrapper around the async IO starting point of the application. Something that we'll be talking during this session, it's about, you will hear the word async IO many times. So basically, we are using the Kivy app within the Python async IO framework. So this means that we'll be able to run the application in a concurrent mode, meaning that we'll be able to have several concurrent functions running within the application. So, and I'm not sure if how familiar you will be with async IO, but with async IO, the main thing is that when you implement something with Python async IO, you will, for example, notice here in this on the function app function or template function, you always need to include this keyword called async in front of def when you define a function, and we'll usually go near to this await next to the functions that you want to be actually blocking in your code. So this await is telling to the to Python just to block here this process.
Mm-hmm. Well, and
yeah,
and maybe
Mhm.
like you say block, but you mean like
Mhm.
almost the opposite of block. Like
Mhm.
in the function call, you're sitting there and you're waiting,
Yeah.
but you're allowing other processes and other like other coroutines to be running on the
Yes.
same thread. And so it's basically like a method of
Mhm.
resource management, so that you can
Yeah.
have multiple concurrent things. So it's like
Exactly.
if I get
Yeah.
here and I'm sleeping for a second, I
Mhm.
let everything else that's trying to run do everything
Yeah.
for a second, and then I try to do
Yeah.
my next thing.
Yeah, that's right. So in our case, we have this app function that we use as a starting point. If you see in line 83, which is it's kind of the no yes line 83, it's the entry point of the app. So we create this instance of the template app, and then we call this app function in this async IO loop, run until complete. This will go to line 46. And here, a pattern that we try to follow when we write apps, it's we want to define here and keep track of the different coroutines that we want to be running at the same time. And here it's a simple case, but yeah, you will see now that when we add, for example, the camera, or if we want to stream the canvas, that will start adding basically more tasks to this list. And finally, the way you start all these tasks at the same time is using this async IO operator called gather, where you just pass the list of the different coroutines you want to basically launch. And yeah, so maybe now, Kyle, you can explain a bit more. Yeah, in that case, we have this template function, which is, I guess, what we'll start to modify and later on include similar coroutines.
Mm-hmm. Yeah, so maybe for now, we'll just keep the template function there doing nothing. Or
Sure.
we could even keep incrementing the counter.
Yeah.
Just to show, but we won't display that text. But this way we know we have one coroutine running here, and we'll add a second coroutine that we'll call stream camera. So maybe I'll just copy the whole line. We'll rename it to stream camera. And this will be a routine for streaming Oak camera. Okay. So one of the things you'll notice in the top of our functions that we typically do is we have this initial little loop while we wait for self.root. So this is a Kivy. This is the root of the Kivy application. So we have this method or this member because we inherit from Kivy app. We don't want to try to do anything until the Kivy app has been established. Sometimes it can take a little bit of time for it to like fully come up and build. So we want to made sure we don't start trying to stick camera images into the Kivy app before the Kivy app exists. So we always start with that. And then we can create forever running while loop. And we can, let's see. Well, we can start off just by doing nothing. Sleep. I don't know, we can give it a different number, and nothing for now. Okay. So now that we've added a second task, we can just append our async tasks list in the app func. So now we will ensure the future of stream camera. And I guess we could print something here just so you can see stream camera is there. And then we'll put template func. Go up here. Okay. So
maybe
now,
you could use the counter here to show that we can, that since it's within the same class, we can share the variables between the different tasks.
Yeah, stream camera. Okay, so maybe in stream camera, we'll show the counter.
Yeah.
Okay, so if I run this with the app button, we won't actually see the print statements. So I will open a terminal. And you'll see I'm already in my custom app demo folder. So I'm exactly where I want to be. If I wanted to, if I was in the home directory, if I just SSH'd onto the Amiga, then I would navigate to apps. I can see which apps I have here. I have the app we're working on, and then also the virtual joystick. I can go to custom app demo, and I can run it with entry.sh. So now we should see, so we'll see 2 counters for every template func that prints, showing that these 2 are running concurrently. And this is running every half a second, so at 2 hertz, and this is running at 1 hertz. So that's why we get 2 counter prints for everyone.
Okay.
Yeah, that's a good little demo to kind of understand that. Okay, should we start? I guess we should define our camera client.
Yeah.
Okay. Okay, so we will need to do some imports. Okay. So we have some FarmNG libraries that we'll bring in. So these are part of the FarmNG Amiga package. So from FarmNG let's see, what would this be? Service client. So we have a generic sort of service client that all of our clients base off of. So the camera client to stream the camera, the CAN bus client to stream or control the CAN bus, all of those inherit off of this client config, which sets the address and the port. And since we're making a camera, we'll also add the camera client, so we can actually create that. We'll need the protos from the camera client. So that would be farmng.oak, import oak pb2. That's what the compiled proto files are named. There's always this underscore pb2 appendix. We'll need the same thing with the service protos. So we'll have the oak protos, the generic service protos. We'll have the oak camera client and the configuration for it. And yeah, that should be enough to start streaming the cameras. To get the stream, but not yet to decode. Okay. Now we can, in the app func, we can define the camera. So we will define camera client here. So the first thing we'll need to do is we'll need to set the configuration. So this is that generic client config. This takes, let's see, it doesn't know where Farming Amiga is. The client config takes 2 arguments. One is the address, which is the IP address that you want to run from. So we could just use something as simple as localhost. And the other would be the port. For camera 1, we can use 50051. And then we can set up the client. Oak camera client of that config. So this creates a camera, an Oak camera client for us with hard-coded values of localhost and port. I figure we could hard-code them in right now, and then we can set up the command line args after so that these can be programmatically sent in. So we'll want to pass that client to our stream camera method so that the method actually gets the client. So then we would add an arg to that function. We can also call it client, and that'll be an Oak camera client. And you can just do these type hints in Python, but they're not actually enforced. Okay, so now what we can do in our loop, instead of doing nothing, we can start checking the client state. So with the generic service client, we have this method called getState, and this is actually something that needs to be awaited. It's coroutine as well. So we'll run await client getState, and then we could print the state. And so this should show us, if we run this, every half. Thank you. It should show us, okay, so we have an idle camera while the app is running. I guess I can't run it and turn the cameras off. If I could use the launcher string, I could toggle it off and show you the cameras. I guess I could go here. We could go to services. We could turn off, we'll turn off Oak 1 and connect to that client, which would be 50052. So now you should see that the service state is unavailable. And if we go back to camera 1 or Oak 0 rather, you'll see that we're back to idle. So the idle state means that the gRPC service is sitting there, it's ready to go, the device is connected, it's just it doesn't have a client streaming it. So once we start streaming that client, it'll switch into the running state, which we'll see soon. Okay, so the next thing we want to do is we want to wait here until the state is, we don't want to try to stream the camera if the state is not either idle or running. It's totally okay for a gRPC service to have multiple clients. So if it's already running, it just means someone else is connected, but that's okay. We can also connect. But if it's not idle or running, that means the device is not ready to stream. So state.value, if it is not in, oops. So we have, we either want to be running service state idle, or we want to be okay. If our state is not idle or running, that means we're not ready to go. We basically we can print the state there, and wait for it. If we are running, then we'll stream the cameras. And we add a little bit of kind of extra logic in here. So I guess we'll wait 1 second for that. So the next step to do to connect to this gRPC service is to create a response stream, is what we call it. And so this is basically because the camera stream is a server streaming RPC. That means we send one request to the service, and then the service sends back many messages. So we're just calling this stream of messages responded from the server response stream. We want to, if we are in a good state, idle or running, let's create that response stream. Since we're looping through this, we only want to create it if it doesn't exist currently. We can kind of, I'll start kind of adding some code a little bit faster. So if the response stream is none, we can create that response stream. And we're using the stream frames method. Gosh, I really wish, I think I'm going to pull it up. Let's see. Farm G. Oh, camera client. So we are using the stream frames method, which wraps basically the gRPC call of stream frames for us. It takes an argument of every n, which is how many frames to skip. So let's say you are doing some very heavy machine learning or image processing. You're doing that on every frame that you receive here. You could decrease the stream rate so that you only get every 5 frames. So this would be 2 frames per second. We don't mind having a faster stream, so we'll use every 1 and we'll get 10 frames per second, which is the default configuration. So that creates our stream. And then now that we have a stream, we can try to read that stream. So maybe I'll just put this block in. We use a try except so that if the Oak camera service is killed for some reason, our app doesn't crash. You don't have to do that. You could just go like directly and read it if you want to. But basically this is, let's get the Oak PB2 stream frames reply from the response stream. So if we look at the camera client, it's using the stream frames RPC. If we look at the oak.proto, we can see that stream frames RPC call takes a single stream frames request and returns a stream of stream frames reply. So that's what this response stream is getting, is that stream of stream frames reply. That's really hard to say fast. There is, if the stream is stopped, so the stream doesn't always have to run forever. It happens to run forever for us because we just want our apps to run. But let's say that you had like an RPC call that would stream 10 frames. After the 10th frame, you would get this end of stream frame, this aio.eof message. So we just handle that cleanly. Basically, is all of this is just handling cleanly if we no longer are getting a response stream. But this line is like the main decoding or main image receiving the image. If we do get this end of stream message, then what we'll do is we'll delete the response stream or we'll cancel it and then we'll set it to none. That way, once the client is in a good state, idle or running again, then we can create that response stream again and start streaming in the future. Okay. So maybe let's see how crazy it would be if we just print the response here. gRPC is not defined. We need we're missing an import. Import gRPC. Okay, so now we're getting some raw bytes. Obviously, it's not readable to us, but you can see that, I mean, this massive packet of bytes is the data, the JPEG encoding of one of the images. So that's pretty cool. We've set up our response stream. One thing that I did miss was we have another check for in here if we're in a bad state, just in case. We already have a response stream. So that would be, it got past this check, it read the response, and then sometime after reading that response and getting to the next loop, the state went to idle, out of idle or running. Then we'll delete that response stream so we don't try to read it down here. So again, that's more just kind of trying to handle cleanly if the service crashes. Okay, so now that we have our response, which is a stream frames reply, so we'll go to that proto definition and we'll see that contains an oak sync frame. So we want to access the oak sync frame from that stream frames reply. So we can say frame equals, what is it? Response dot frame. That acts as that, and then this is of type to be from the oak proto definition. And this is a, what did we see it was? An oak sync frame. Again, we're just declaring appends here, which makes it a lot easier to track what data type you're working with. I don't know, Edgar, if you want to add anything to that about the hinting.
No, I think it's fine. Highly recommend it to use typing. Yeah. Makes code readable. Yeah.
It makes it way more readable. You just need to make sure you, as long as you use it, like if you type hint wrong, then it could get you really confused. But as long as you use it properly, it's definitely makes your code better. Okay, so in this oak sync frame, maybe I'll just bring this proto definition up on the side. In this oak sync frame, and look at the proto definition of that. We have a left image, a right image, an RGB, and a disparity image. Conveniently, that matches the name of our tabs and our tabbed panel. So what we could do is we can make a for loop over those names. So we'll say for view name in RGB, disparity, left and right. We can try to decode the image. In order to decode the image, we'll need to set up an image decoder. We like to use PyTurbo JPEG, which is fast JPEG decoding for Python. So you'll import from Turbo JPEG, import Turbo JPEG, and then you'll need to make sure you add this to your setup.config file here. So you'll see we added PyTurbo JPEG right there. That way we can import that, and that'll install when you run your entry.sh script or when you click on the button. And yeah, so import that, and then let's create it on. So when you run the Turbo JPEG construction, it's kind of a slow call. So what we do is we initialize it ahead of time. That way it's already set up and it's ready to decode. And then when we want to use it down here, we can do self.image decoder dot decode. And here's where, so if you're familiar with Python, you can use this getAttr method, which would be to extract the view name. So this would be essentially like calling frame.rgb or frame frame dot disparity. So it lets you access members of the object you're referencing. So object that you're going to, and then the attribute that you want to access from it. That way you can do it programmatically and loop through with these strings. Just kind of convenient to use a for loop. Okay, so we've gotten our image, but if you looked at the oak frame proto, so frame.viewName would give us the oak frame, let's say left, then that contains image metadata and then the raw image data. So we want to decode the image data, the raw bytes. We access that attribute, and we could also do something like, of course, we don't need to do this because we know it's always going to be image data, but we could do something like, get adder image data. But we don't need to do that. Now we have our decoded image. The next thing we need to do is we need to create a Kivy texture that we're going to place in the image widget in our tabbed panel. So we'll create a texture.
You missed to declare, Kyle. Yeah, you missed to declare the variable, the returning variable.
Sorry.
When you call the code, yeah.
Yes, thank you. Yeah, we want to get actually get the image from the decoding. Okay, so once we have that image, we have a decoded JPEG image that we can look at, but we need to bring that into the Kivy atmosphere. So we'll create a texture that's the right size of the image, and we'll use the BGR color formatting. We add these two steps. We flip vertical, which we found was required with the Oak cameras to get them into the Kivy texture. And then lit buffer is we are writing the JPEG image into that Kivy texture. So basically we create a blank Kivy texture that we then flip the vertical and then write the data. So the bytes of the JPEG image bytes, but decoded bytes into the right format into that texture. And then the last thing we can do is we can display it. So now self, which is our class that's inherited the Kivy app, .root, .ids, now we can access the IDs, which are RGB here, left, right, and disparity. Oh, look, we need to change that. So .viewName .texture, and an image has a texture. The image widget has a texture property. We assign this texture to that image, and now that should stream. If we put a try on the image decoding, we can capture that exception and just print it. And that'll help if something fails in the image decoding. Maybe you got like an image with weird, like when you start up, maybe there's an image with weird formatting or something or incomplete. It won't crash your app. So now we can run that. And we should see images coming in. Okay. Well, we're not getting images.
Started with
right.
the terminal to see if we get something.
Yeah. Name texture is not defined. Nice. Okay, missing some imports. Okay. So yeah, with all of the try and accept, on one hand, it's nice because then if an edge case comes up, it'll handle it cleanly. But when you are developing, maybe you'll miss a few things that you need to add. Okay. Let's see if we're missing anything else. Okay. Now it looks happy. Let's check our screen. Hey, we have an image stream. Okay, so we have RGB, we have the left image, the right image, and the disparity image all streaming into our app.
Nice.
So yeah, let's see. We're over time again. Surprise. One note: if you look at the actual implementation of the camera streamer app, so go here, camera streamer source main.py. Make that big. Let's see. What we did not set up here, but isn't too crazy, is setting up command line arguments that can be passed to your app class. So basically, we've already set up the arg parser. I'm trying to get these side by side reasonably well for you. So we already have the arg parser set up where you can add additional arguments here. So you can add things like the port, which is the camera port. So that's that 50051 value we hard coded above. There's the stream every n argument if you wanted to decrease the number of frames per second, and then also the address argument, which is the IP address of the gRPC service. So if you wanted to run your app from your computer, you could set the address to be the IP address of the Amiga and run it there. So you can add those, and then you can pass them to your app. So you would add them here in the template app call, and then process them, use them up top. But that's, yeah, I think a fairly straightforward thing. And anything else we didn't cover, Edgar?
I think that's more or less it. Yeah, maybe mention that if you are building, so that's kind of the basics to get the data from cameras. So yeah, if you are building any solution using image processing or computer vision, so if you can scroll down to the stream camera function, yeah, maybe you can add, yeah, a bit down after the decoding in the image. Yeah, here is the starting point where you can take this image, which is an MP array in this case, and do any processing you want to do with the camera.
Yeah. I don't think we have CV installed as one of our requirements in the virtual environment. But yeah, you could do that resize image, whatever size you want it to do. But yeah, that's a good call. This is like the image processing block. Yeah. Just a minute. Thank you. Yeah, that is oh, and one thing to mention, when you do add command line arguments, you can set them in the entry.sh script. So if you look at the camera streamer, I'll bring that back up, main.py, in entry.sh, you'll see that the port argument that specifies we're using OG0 is set there. So you can always change that to be a different camera.
Mm-hmm. Yeah.
So yeah, hopefully this helped.
That was great.
That was great, you guys.
Sorry, am I echoing?
Better now. Now we're not hearing you at all, Ren. Middle ground.
How about now?
Perfect.
Yeah, that was awesome. I think I can write a new app today. Thanks to you and Edgar. Thanks, Hector, for watching the tractor. And then next Wednesday, we're going to show off our Xbox controller driving.
Yep.
Like, comment, subscribe. Anything else, Kyle or Edgar?
Yeah, just hopefully this is helpful. Any questions, please YouTube comments, or we have our discourse channel, discourse.farmng. You can ask questions there. We'll post we already posted that this was happening. So That could be a good thread to ask any clarifying questions on.
We should put next time the link on the Discord and subscribe here.
Yeah, good call. We'll add that. Good idea.
Great. Thanks again, you guys.
Yeah.
Thank you.
Thank you.
All right.